Hello, this is Mrs. Huntley. This is Module 3, Lesson 8, Similarity. You should be on page 57 of your module. And your essential question for this lesson is, how can I prove a similarity if the shapes do not have the same orientation or are not located close together? So we have some figures here. We have S and we have S sub O. And we're looking at it and the question is asking, are these two figures similar? And it appears that they are. I would have to get some measuring tools and perhaps check the diameter of the circle part and check the length of the flat edges and see if we can come up with a scale factor. But just by eyeballing it for the sake of our discussion, I'm going to say it appears that they are similar, but we really need more information to be sure. We need some given information, maybe about some segment lengths or something like that. So then the next question, can we dilate one of the figures so it's the same size as the other? And again, it appears as though we can. It looks to me, when I'm just eyeballing it, looks like this is about half the length of this one. And this circle here looks like it's about twice as large as this one. So it looks like one is about half the size of the other. So. I think we could dilate the figures. Maybe make this one half as large so it's the same size as this one, or grow this one by 2 so it's the same size. But I'm not sure yet, okay? But I do know, it says, would the dilation alone be map one figure onto the other figure? So if I grew this figure from where it is, it would just be larger, but it'd still be like over here, and it would be kind of upright, whereas this one's laying on its side. So no, a dilation alone isn't going to work. I would need a dilation followed by a rigid motion. That's from last module, either a rotation, a translation, or reflection, or some combination of the three. So if you thought we were done with rigid motions, we're not. They're back. So let's go on with the lesson and see how we're going to do this. Okay, example 1, and don't let all of the words freak you out. I'm going to walk through this with you, and we're going to make it to where it's not that confusing and that difficult, okay? The first thing, your copy is really not good. It was shrunk down, it was copied from another resource, and it didn't copy over well. So I've labeled my drawing with ABC, A prime, B prime, C prime, and then A double prime, B double prime, C double prime, and then I also put in the numbers on the x-axis and the y-axis. You don't have to do that, but to me, it was very, very difficult to figure out what they were talking about without fixing my drawing first. So let's read the directions together. In the picture below, we have triangle ABC right here that has been dilated from center O by a scale factor of 1/2. So that means it got smaller. And that's notated by A prime, B prime, C prime. So that's this one here. So it got shrunk from here to here. We also have triangle ABC, this one over here, which is congruent to triangle A prime, B prime, C prime. So they're saying that this one is the same size as this one over here. So if I bring this over, if I trace this one, I can figure out what rigid motions maybe got this one to come over to here, and I'm looking at it and it looks like it's just a translation, and one's going to map on top of the other pretty perfectly. So they are indeed congruent to each other. And remember, congruence means our line segments are the same, our angle measures are the same, and there's some rigid motion that can match one on top of the other. So this, if I drew a vector from B prime to B double prime, it looks like I could go right along that vector and one would map onto the other one. Don't need to do that. I just wanted to demonstrate that to you. So now it says, describe the sequence that would map triangle A prime, B prime, C prime back onto this original one. So how are we going to tackle this? So let me just give you a couple of steps. And the way to do this is you adjust the size first, because usually you won't know what rigid motion got you there, so you can't just back it up. So we're trying to prove that this one is similar to this one. We're going to adjust the size first. So we're going to come up with our, well, we know if we're trying to change the size back, if we shrunk by 1/2, we're going to have to grow this one by 2. So I need to know where the original vertices are. So A double prime is at x equals 11 and y equals 4. Whoops. And B is at x equals 13, y is 5. And C is at x equals 15 and y equals 3. So if I'm dilating this by a scale factor of 2, I need to calculate where my new points are going to be. So we'll call it A triple prime. Getting crazy here. So we have A triple prime is going to be at 22, 8. So come out to 22 and go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be where A triple prime is going to be. B triple prime. 13 times 2 is 26. 5 times 2 is 10. So 26 right here, and then up 10. And that's the top line. So it's going to be B triple prime. And then C triple prime. 15 times 2 is 30. 3 times 2 is 6. So it'll be at 36. There's 30. 1, 2, 3, 4, 5, 6. Right there, and that's C triple prime. I am going to use a straight edge to draw those lines. Okay. Okay. So it looks like I've grown my shape. I'm going to lock this in place because I'm going to move some things around and I don't want this to scoot around. So I'm going to lock that. Okay, so that won't move if I try to drag it anywhere. So now I'm going to trace it. And I trace my drawing and I'm trying to figure out how I'm going to get back to my original. Again, I could draw a vector. Draw my vector in red. From B triple prime back to B, and then I can trace my drawing and travel along that vector, and it's going to get right back onto the original. So if I'm writing this out, I would say 1, row, triangle, A double prime, oops, by a scale factor, or R equals 2, and then 2, I'm going to translate along vector, B triple prime, B. And then I'd have to draw that arrow on top of that. Okay, I hope that makes sense. So we're growing it by a scale factor of 2, take care of size first, and then figure out which ridge of motion will bring the shape back on top of the original. Let's move on to the next one. Okay, here we have a picture below, and again, I just put in the letters because these I had a really hard time, especially when they use F's and E's. They look exactly the same to me when they're really tiny. So I made them a little darker. So this is your D prime, E prime, F. I'm sorry, hang on a second. Did I mess up the F's and the E's? Okay, this is E prime, this is F prime. Here's E, here's D, E, F. Okay, and then this is my E prime, E double prime, F double prime, D double prime. Okay, so we're trying to figure out, okay, in the picture below we have triangle DEF, this one, and it's been dilated from center O by a scale factor of 3, so it grew to this one, okay? We also have triangle D double prime, E double prime, F double prime, which is congruent to this one. So they're saying these two are the same. So they're showing me that they're congruent to each other. Now what we're trying to do, the first direction says we want to describe a sequence that would map this one back onto the original. So if it was dilated by a scale factor of 3, to get it back to its original, I've got to shrink this one by a scale factor of 1/3. So I need to figure out where all of these points are and then dilate them by 1/3. So E double prime is the easiest one. It's at 0, 0. So E double prime is at 0, 0. D double prime is right here, and that's at negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, negative 12. And then down 1, 2, 3, negative 3. And then F double prime is at negative 9, negative 1, 2, 3, negative 6. Okay. So if I am shrinking each of these coordinates by a third, I can think in my head that I'm dividing by 3, but I'm really multiplying by a third. So anything multiplied or divided by 0 is still going to be 0. So E triple prime is still going to be at 0, 0. That's the easiest math we're going to do all day. D triple prime is going to be at negative 4, 1, negative 1. And F triple prime is going to be at negative, let's see, negative, you know what, I did that kind of fast probably for some of you. So I'm multiplying everything by my scale factor, and I did it in my head for D double prime, but for F double prime, it would be negative 9 times 1/3, which would be negative 9 over 3, which is going to be negative 3. So negative 3, and then I'll do the same thing with negative 6 times 1/3, which is going to be negative 6 over 3, or negative 2. Hope that helps you. I'm going to erase that work, but I just wanted to add that in there just so you knew what I was doing. I was just doing it in my head, and I apologize that that was probably a little bit too quick for some of you. So, okay, let me go ahead and draw my new shape. Here's 0, 0, and then negative 4, negative 1 is right there, and negative 3, negative 2 is right there. And I'm going to connect it up using a solid line, a nice thin one, but we'll go with blue. And I should label this too. So this will be E, oh, that's fat. Let me see if I can get that to not be fat, because this is going to be a tough drawing anyway. Okay. So this is going to be E triple prime, D triple prime, and F triple prime. And I'm going to lock that in place so that when I trace over it, it doesn't move anywhere. And this is where you can be using your different colors to help you keep track of, you know, what you're putting where. So I would definitely have made my dilation in a different color. Now I'm going to trace over it, and I'm going to try to figure out what rigid motions I need to get this guy to map back onto the other one. So the first thing I'm going to do is draw them closer together. So I'm going to kind of scoot this over. Maybe I'll draw a vector from E triple prime to E. And I'm going to make a note of what I'm doing here. So 1, dilate. By a scale factor, let's say R equals 1/2. R equals 1/2, and then second, translate along vector E triple prime E, and I just have to draw that in. Now that I've translated and my e's are next to each other, I'm going to rotate until D triple prime maps to D. So I'm going to rotate until D triple prime maps to D. And then finally, I'm going to reflect over DE. Remember, we reflect over a line. We can rotate around a point. Ooh, I didn't say what I'm rotating around. Rotate around E, point E, until D triple prime maps to D. So that would be all my steps. And yes, they are long steps. So I got to draw that vector in from E. And now I'm going to see, rotating with this program doesn't always work well. It doesn't quite do what I want it to do. And I can't switch the overhead. Okay, why aren't you? There we go. I just couldn't do it with all the other stuff. So let's see if I rotated enough. All right, I rotated enough. And now I would have to reflect. Let's see if it'll let me reflect. Let's see, flip. It will. Ooh, up, down, I think. Nope, undo that. Right, left. I want to just reflect over DE. You know what? Hopefully you can visualize it, because I don't think this computer program is going to let me do it. So I got to draw them close together, and I'm doing that with my translation. Then I'm rotating around point E until D maps to D prime, or D triple prime maps to the original D, and then I reflect over that line DE, and then F will map to F prime. Okay. Hopefully this is starting to make sense a little bit, and we're running kind of tight on time, and I haven't even gotten to the third one yet. This one, it's telling us in the diagram above, triangle ABC is similar to triangle A prime, B prime, C prime. Describe a sequence of a dilation followed by a congruence that would prove these figures to be similar. So the first thing we have to do is figure out a scale factor. And again, because this is in a grid, I can count units. I don't have to get anything else to measure with. So AB is 2 units here. A prime, B prime is only 1 unit. And let's see, CB is 1, 2, 3, 4, 5, 6 units. And then B prime, C prime is only 3 units. So you might have already figured out that I'm shrinking this one. This is my original. I'm shrinking it by a scale factor of 1/2. If you're like, how did you figure that out? Let me show you. Okay, so A prime, B prime is equal to the scale factor times the original length of AB. So A prime, B prime is 1. We don't know the scale factor. Original AB is 2. I want the scale factor by itself, so I'm going to divide by 2, and my scale factor is 1/2. So the first thing I need to do is take care of size. So I'm going to say 1, dilate, figure ABC by R equals 1/2. So figure out where your points are. A is at -2, 4. B is at -2, 2. And C is at -8, 2. Okay. We'll call it A sub 1, because it's the first move, and this is already with a prime here, so I don't want to do that. So when I dilate, half of -2 is -1, half of 4 is 2, B sub 1, half of -2 is -1, half of 2 is 1, and then C sub 1, half of -8 is -4, and half of 2 is 1. So let's draw in that dilation. So A is at -2, I'm sorry, -1, +2. This is going to be our A sub 1, and you can use a different color for this one. B is at -1, -1, and then C is at -4, +1. Connect those up with a nice clean straight edge. Go with blue. I'm going to lock that in place. Oh my goodness. Oh my goodness, that's not what I wanted to do. Let's see if I can get it matched up. Okay, lock that in place. Now let's see if I can lock this in place. There we go. Now I'm going to trace this. And I'm just using a different color. Okay, that didn't work. Let's undo that last one. There we go. Get a nice straight line. And then I'm going to group those together. I know, I went over in time. I'm sorry. Okay, so now if I drag this, I can draw a, I can tell right now, I'm going to draw a vector from A sub 1 to A prime. I'm going to move my figure along that vector. And once I'm down here, I can see I need to reflect over AB. So my second move, after I dilate, I'm going to translate along vector A, we'll just call it A for right now, to A prime. And then I'm going to reflect for AB, A prime, B prime. Remember, we reflect over a line. Okay, I'll draw in the vector. Here we'll draw in the sub 1. Oops. There's the sub 1 and the vector sign. So again, deal with your size first, then figure out your rigid motions. We don't have time to finish up the rest of this lesson, so we will finish it in class tomorrow. We have a couple more examples and then some independent practice. So have a good night. I'm sorry I went over 3 minutes. I will try not to let that happen again. See you tomorrow.